Hello, welcome to this video focusing on the development tools that are available for the Zynq-7000 all-programmable SoC family. During the next few minutes, we'll provide you with a high-level introduction to the Zynq-7000 all-programmable SoC. We'll also give you a quick glimpse into the Xilinx tools that allow your product teams to work in parallel across every task, from system design through software and firmware development, hardware design, and ultimately the creation and deployment of the bit streams and software image files that form the core of your product. Along the way, we hope that you'll see how these tools can be used largely autonomously, where co-simulation and co-debug capabilities for Zynq bridge the gap between your software and hardware development teams. The Zynq-7000 device, comprised of a dual-core ARM Cortex-A9 processing system and peripherals, in Xilinx's most advanced programmable logic, enables product developers to add peripherals, accelerators, and other functionality directly into the Zynq's programmable logic without the need to solder another discrete part to the board. These custom IP cores, instantiated within Zynq's programmable logic, connect to the processing system just as the built-in hardened blocks of the processing system itself are connected through AXI interconnects. The result is higher performance at lower cost and complexity than previously discrete designs. But in order to take advantage of this approach, the tools must address every phase of software, firmware, and hardware design, development, debug, and deployment. Developers of systems based on the Zynq devices from Xilinx have ready access to a range of tools that support all tasks, from design through to deployment. Xilinx tools address the specific problems faced by product development teams, including system architects, firmware engineers, software developers, and hardware designers. Xilinx tools can be described as tightly integrated but loosely coupled. These tools allow each development team to proceed largely independent of the others, and then combining the hardware, firmware, and software designs as they become available. Xilinx co-simulation and co-debug capabilities allow integration and test even when one team may be ahead of the other. Once the system architect has defined the system, including basic design and hardware-software partitioning, someone will need to configure the I/O pins and integrate custom embedded IP cores. Xilinx Platform Studio, or XPS, makes configuration of the Zynq family straightforward by offering a graphical interface that transparently takes care of all level details required to configure the clocks, memory controllers, I/O, AXI interconnects, and memory interfaces. XPS makes it easy to add AXI IP cores from the Xilinx catalog for embedded IP, and it also performs automatic error and correctness checking to ensure that your design is both electrically and logically sound. The Zynq device includes a powerful dual-core ARM Cortex-A9 processor and a range of integrated peripherals. Xilinx SDK is a software development environment based on the industry-standard Eclipse framework. It includes Xilinx-specific extensions for integration within the Xilinx tools flow, with specific emphasis on development of both bare metal and Linux applications. Xilinx SDK includes project and application templates, board support packages, memory and peripheral tests, pre-configured compilers, and much more. It shares data with Xilinx hardware design tools for the creation and build of custom board support packages, bootloaders, and applications, and it provides out-of-the-box debug connectivity. With Xilinx SDK, developers have everything they need to deploy solutions immediately. For Linux developers, Xilinx Petalinux complements the Xilinx SDK by providing a full, commercially supported Linux distribution that includes an array of configuration, build, deploy, and debug tools. Like Xilinx SDK, Petalinux is also hardware-aware, automatically generating Linux BSPs to match the custom Zynq design created in Xilinx Platform Studio. Petalinux brings the ability to configure and build the Linux kernel, kernel modules, applications, and bootloader to Xilinx SDK. Petalinux also includes a fast, functional QEMU system model of the Zynq processing system. Now, software development can take place even before physical hardware is available. Like the automatically generated Linux BSP, QEMU is also configured for the custom design defined in XPS. Within any system that utilizes a processor, firmware plays a crucial role. As we described a couple of minutes ago, Xilinx SDK already includes a full C and C++ development environment for application and library development. To address firmware development, SDK uses this same environment along with its ability to understand a XPS-defined custom design. When these functional SDK capabilities are combined with a Xilinx-provided source code, reference designs, and technical documentation, developers have everything needed to create a custom first-stage bootloader, including secure boot and multi-boot options, or a standalone board support package. The Zynq is unique within Xilinx product portfolio because it includes an ARM-based processing system tightly integrated with programmable logic. Though it is unique in this way, from the perspective of Xilinx hardware design tools, the Zynq programmable logic continues to be treated exactly like a typical Xilinx FPGA. Developers who are using the Zynq devices within their designs can be confident that the full suite of tools provided by Xilinx for design and planning, IP integration, and the implementation of netlists and bit streams continues to provide the same value and capabilities to which they have become accustomed. The Zynq devices allow integrated product designs that until now just could not be created. Such designs require development tools that provide a high degree of integration while also retaining a high degree of autonomy. That is, within a product team comprised of separate hardware, firmware, and software groups, it's important to avoid stalling one group based on a dependency from another. Xilinx addresses just such issues through a combination of hardware-software co-simulation and hardware-software co-debug. Xilinx co-simulation solutions use fast functional simulators, cycle-accurate simulators, and hardware-in-the-loop. Our co-debug solution uses ChipScope Pro to stop the system on a custom hardware breakpoint, and Xilinx SDK to stop software execution on software breakpoints. The Xilinx co-simulation and co-debug capabilities have proven to allow development, integration, and test phases to continue even while hardware may lag software or vice versa. As the firmware, hardware, and software development progresses independently, you'll soon need to glue all the pieces together, including the bootloader, bitstream, and the OS images, so that you can move on to full system integration and test. Xilinx SDK includes a bootable system image generator that does exactly this. It collects, formats, and assembles each of these custom elements, and then it manages the write of this data to the Zynq platform using JTAG, network, and more. Until now, each of the tools that we've spoken about is available directly from Xilinx. However, we've worked hard for over 2 years to create a comprehensive ecosystem for Zynq. And this presentation would be incomplete without a mention of the dozens of partners who provide off-the-shelf solutions for hardware intellectual property, system architecture development tools, design services, operating systems and middleware, and development tools. Zynq is not just about the availability of silicon. It's about a full solution including silicon and board availability, end-to-end development tools, technologies for increased safety and security, and a comprehensive Zynq ecosystem. Today, we hope that we've provided you with a glimpse into how Xilinx tools address the different development challenges faced by engineers as they create the next generation of highly integrated products. These Xilinx tools enable our customers to address every critical task from system design through software development and Linux OS issues, through hardware design, co-simulation, and co-hardware debug. Finally, to allow you to create and deploy everything that forms the core of your product. For more information on the hardware, software, and firmware development tools for Zynq, please visit xilinx.com/Zynq and click on the link for Development Tools.